Alright, so we are working on day number 3 of this inverter project. It's been pretty difficult, and so we spent a lot of time doing that. And so now we've already got everything ready to kind of test it out and see if it's going to be able to support all of these wonderful tools and things. Egypt told me that once we plug 2 in that exceed the wattage, it's going to short out or trip this breaker or something. So I can't wait to see what's going to happen, because I want to plug in this, because I've always been told these things are huge electric suckers. So I'm going to try that.
Yeah, did you have fun last night trying to get that on the wall?
Not really. I was really scared.
I'm still in pain.
I know. You hurt yourself.
Folks, we had a bear of a time getting that mounted on the wall last night. I finally had to take the car jack and place it up underneath the inverter and literally jack it up and hold it steady till we could get it level with the bolts, and then push it on. And it actually fell on us once, just a short distance, just a few inches, not much, but boy, I tell you, that thing is heavy. That thing weighs somewhere between 150 and 180 pounds. And so, anyway.
I think it seems like it weighs more than that. That capacitor end, it is a capacitor, right?
No, that's transformer.
Transformer end. The transformer end of that thing is super heavy. And Egypt was saying, hey, can you lift it? And I could, lift it up and move it, but there was no way that I was going to be able to get on one side and then lift it up like that. I mean, because it would have had to go probably, what, a foot, 2 feet?
Something like that.
And I'm not that strong.
She's strong, folks. Neither one of us are that strong. Anyway, if you get one of these inverters, I highly suggest you have some help. 2 good, strong fellows with you, or something when you do this, or some serious handholds, or a cherry picker, or a hoist, or a jack, or anything to help you lift that into place, because woo-hoo, that thing is a bear.
Poor guy.
Anyway, we're going to go introduce you to this thing and show you its bells and whistles. We can at least get started and let you see how this works. So let's do it.
Okay, the things we're going to test include that heat gun there, my beautiful pink straightener, the blow dryer, some power tools including this belt sander and router. We're going to plug in the fan there, that vacuum cleaner, and wave to the camera, sexy Egypt. And over here, I think we're going to plug in this.
Yeah, let's try this monster.
Lovely
6.5 horsepower shop vac.
So those are some of the fun things we're going to do, to plug in and see what happens to the inverter and if it can support them and if we fry out everything or not.
As you can see, we've got a little panel set up here on the wall. It's temporary. That's why the wiring looks like it does. It's not going to be. It's not permanently installed here. It's just while we're testing it. But anyway, you can see we have our battery bank here. We've got our battery cables that we completed in the last video installed and ready. This is the configuration that will appear in the solar generator. It seemed to be the best way to install these batteries in the solar generator for weight distribution and things like that. And then also, of course, we have the inverter itself, a 12 kilowatt, 12,000 watt, 48 volt inverter made by Sigineer Industries. And boy, I can't wait to turn that thing on and test it out, folks. You're going to be watching us turn it on for the first time. Of course, it is supplying power to this panel right here, a 100 watt panel that so far we only have 2 15 amp AC breakers hooked to that supply those 4 15 amp GFCI receptacles there. These 2 220 receptacles, one's a 50 amp and one's a 20 amp, they are also going to be GFCI, but as you can see, I have not yet received the breakers that I ordered for them. They're not in yet, so we're not going to be able to test that today, unfortunately. As I showed you last night, we have this out back 60 amp charge controller that is not yet hooked up and I have a PV combiner box for when I do hook up the panels and get ready to do that. But tonight, the inverter is the star of the show. So let's get going, get her turned on. All right, folks, I thought I'd show you the underside of this inverter first before we get going. See if I can put a little light under it for you there. As you can see, I installed two rather large 4-aught copper mechanical lugs in here to hold those 4-aught battery cables. The manufacturer recommends an aluminum mechanical lug, but I could not find one in a 4-aught size, so I had to go with this copper. The problem is that because of the design of these covers, these lug covers, there's no way I can get the lug covers back on these things. So at least for now, till I can find some 4-aught mechanicals, that's the way it's going to have to be. I'm just going to have to be very careful. And then also, I think I pointed these out before, these dip switches. You'll see a couple of them are switched to 1. Dip switch SW5 refers to the power mode. If it's set to on, that means that power is coming from the batteries as a priority. If it's set to 0, that means it's coming from AC, as if you could plug in either a generator or utility power to this to keep power flowing through it. SW4 is for 50 versus 60 hertz. We're in North America where we use 60 hertz, so it's set for 60 hertz. But as you can see, we have not powered on any of the AC switches yet. We're just waiting to do this. We've got our ground lug hooked up here. The ground lug goes into the panel where it joins a ground lug, comes back out through this gray wire where it all goes to a ground lug outside. So we're going to try to keep things safe as we go here. This inverter has a built-in transfer switch for AC power. Now folks, one thing you should know about this inverter is that there is no internal bonding with it. Ground and neutral are not bonded within this inverter. So that means, number one, that this should have its own dedicated load center panel or main panel for the AC part. Do not connect this to your home utility supply or try to treat this like it is a grid-tied inverter. It is not designed for that. That's not what this is. I have it connected to AC here at the shop because the AC allows me to charge these batteries, but that is the only reason why AC would be connected to this. Never ever connect this inverter to your home system without consulting an electrician, preferably an electrician who's very familiar with solar and generator hookups and things like that, not your run-of-the-mill electrician. So, but anyway, getting back to it, this inverter is not internally bonded. That means that the neutral and ground are not, they don't share a wire. And in an electrical system, an AC system, they should be bonded in one place, not more than one place, but just one place. Typically, in a home, it is done in the panel. And that's what I've done here on this dedicated standalone panel that only serves or is served by this inverter. Very important to keep that in mind. Now folks, I'm not an electrician. This is just out there for your information. You need to know that this inverter is not bonded, but I'm going to show you how I did bond neutral and ground. It's inside the panel here. And you know, this can get really confusing, and there's a lot of mystery surrounding electricity, and I must admit I'm still mystified by some parts of it. I've done electrical on and off, you know, on my own, some electrical work at my own places over the years, and even I get confused about this stuff sometimes. But I want to point out the neutral and ground bond to you. First of all, here's the panel. It's called a load center. Over here is the ground bus. This is where all ground wires come in for the system, okay, including the ground wire from this inverter, okay, comes up into here and ties into this ground. Then it goes out via that gray wire out to a ground lug outside. So everything in the system is tied into that ground bus. all the grounds are tied together. Neutral and ground are tied together in one spot only, and it's right here. This little, what we call a ground jumper, and I'll get it in there as best I can, this actually connects to the neutral bus and to the panel, which is connected to the ground bus. So all this serves as a ground, okay? This is important for safety. You want to make sure that neutral and ground are what we call bonded. Now, sometimes you'll read or hear electricians talking about the neutral being lifted. Okay, bonding and lifting are sort of opposite terms to one another. Bonding means that ground and neutral are connected. Lifting means lifting of the neutral bond or something like that, means that they're disconnected. That's really all it means. Try to take away some of this mystery. And if there are electricians out there, you know, who have more specific information they want to share, by all means, please make a comment, because as I said, I am not a licensed electrician, and you know, I think I know enough about this to get by, but you know. As for those of you who see what a mess it is in this box, by the way, keep in mind this is just temporary setup. This is not as pretty as I'd like it, but it'll get better when we install it in the mobile equipment generator. So, now folks, one other thing I've done is I have sort of tied these battery cables together, the ones that go up into the inverter. The length on these cables isn't very long, but they say that this does reduce inductance, or the tendency for wires to leak out a few of their electrons as they go through. These being big wires, lots of amperage, but not high voltage, 48 volts. Yeah, I'll do it anyway, just to be sure. Anyway, let's kick this thing on and see what we get. Well, folks, here we go. Started up. I've got it in power saver mode. Reason being is there's no load on this yet. The other thing I've done is I've gone ahead and I connected the inverter to wall power. What this does is it reintroduces utility electricity into the inverter so that we can recondition, charge, float the batteries, and right now it's undergoing what's known as a fast charge. And it'll do this when it first starts up, as it gets to know the batteries. It'll begin to charge them until such time as it feels they're fully charged, and then it'll shut down and switch back to inverter mode, so that the batteries are just ready to take on any load. But when the batteries get to a certain level of depletion, this will kick on again and do another charge, either a fast charge or a float charge, whatever the case may be. I'm going to let it run through this, and then once it's done, I'll unplug it from the wall. We'll go through inverter mode, and we'll begin powering some things up.
What's up?
Well, apparently you're on the bench.
Well, I don't know what to do. I'm just waiting.
Yeah.
Instruction or not.
There's a lot of sort of waiting with this. We've got to wait for it to fast charge the batteries, and then we'll get to play with it. It's coming. It's coming.
Well, what do we get to do now?
I don't know. Want to get something to eat?
I already had a little baby peanut butter sandwich. Then I was going to make popcorn.
Well, let's get some popcorn while we're waiting.
Okay.
And we'll come back.
Hey, look. That light's not blinking, it's green.
So we've gone off of fast charge, and now we're on float charge. That means that the inverter is done playing with the batteries and getting them up to the charge level they want them to be. Now it's just keeping them at a float charge and keeping a steady amount of electricity flowing through them so that the batteries are fresh and ready all the time. So what I'm going to do is I'm going to shut this off because it's currently in AC mode, and I want to go to this little dip switch underneath here. I want to switch it back to inverter mode. That means that it will begin primarily taking power from the batteries now. So we'll begin using the batteries to do this. And when I switch it on, I'm going to switch it on back to power saver mode, because if you're not drawing a load, why send a lot of power through the inverter? Have it save as much as it can. and it says power saver is on. 243 volts, and there's currently no load on it right now. It says that the battery is at 53.2 volts, and it's sending out power 243 volts, or it can. So there we go.
But
now, because it's in power saver mode, I'm sorry, go ahead.
those green lights are off again,
They are?
aren't they?
Yes. And I guess it trips them. That's interesting. Let me see if turning it on here turns these on. It does. Okay. So that's good.
But if it's not on, it won't work if it's on saver mode then.
Well, let's find out if it does.
Oh, okay.
Because, let me turn it back off and I'll get it to saver mode.
Okay.
The reason I say that is because the purpose of power saver mode is every 6 seconds, this inverter goes looking for a charge against it. Okay? It's looking for a load from an outlet. If it finds one, and if the load is 25 watts or more, it will automatically kick on the regular mode, what we call line mode, or inverter mode. Okay?
Okay.
So let me turn it back on. It's now in what we call power saver or standby mode, as it's called in certain inverters.
And another thing, it's got that battery number. Is that the right number?
The battery voltage?
No, that little dial. There's a little baby dial
Oh,
there.
this, the battery type, yes. Before I hooked up the batteries, I selected the type of battery I have. It tells you right here what setting to put that at, depending on the type of battery you have.
Oh, okay.
And I have absorbent glass mat type 1 batteries, so that's what I set it at. And by the way, folks, this particular inverter, not all the inverters made by Sigineer, but this 12 kilowatt and I think maybe the 15 kilowatt inverter can both, they have a setting here that says 9 on this battery type selector. It says 9 and it says not used. However, in the 12 kilowatt and the 15 kilowatt versions of this inverter, this is the 12, this allows custom setting in case you have automotive batteries, you know, like from a Nissan Leaf or you know, a hybrid vehicle that uses these special automotive batteries, that you can custom set the voltage, charge, floats, all that good stuff for it. So in these larger type inverters made by Sigineer, you can actually use automotive batteries and they get along very well. So it's kind of cool. Anyway, where were we? Oh, we were going to plug something in. Right now it's in standby, or what we call power saver mode. So let's just try something with low wattage and see, and plug it in to one of these outlets and see if the system will recognize it and kick it on, and see if we'll kick on those GFCI, one of those GFCI plugs, or all of them.
Well, you know, I always thought that, you know, electronics like these things
You
here,
want me to-
yes, because I can't fit in there, used a lot of wattage, but this one's actually, I think, our lowest powered tool.
Yeah, the
not
straightening
tool.
iron, or whatever.
Yes, and it's what, 95 watts, I
Mhm,
think.
95 watts.
So this is the lowest wattage item we have that we're going to test.
Okay.
And so now it's not picking it up yet.
Yeah, here's the thing, it's not finding it. And I suspect the reason why is because there's no power, because these are GFCI circuits, and because we are in standby or power saver mode, there's no power going to these, and so it's not sensing these. So perhaps if we had a regular outlet that was not that is not a GFCI, it may work for us.
But you want to use GFCI, correct?
We do, for safety, yeah, because this is a piece of outdoor equipment. Okay, folks, here's where we start getting crazy. Our 20 amp, 220 volt circuit breaker, GFCI circuit breaker came in. So we've gone ahead and installed it up there. It's the one with the white tandem switch on it. And then of course we have our two 15 amp 110 switches, all connected to 4 110 receptacles and the one 220 receptacle. We don't have our 50 amp in yet to test, but soon, suffice to say, as soon as it arrives, we'll be testing it. But as you can see, we have a whole bunch of stuff. Every single outlet we have available is filled with something. The total available wattage of all the things plugged in here, and we have a hair dryer, a heat gun, a router, a belt sander, a small AC here that I use in the shop, my table saw, which is a large cabinet saw, a microwave inside of the house, and the shop vac that we showed you earlier. Total wattage, rated wattage on all those is 12,375 watts. Now this inverter is rated for 12,000 watts. And so, you know, the inverter should be able to handle most of this before it shuts down, before it overloads and shuts down. However, I fully expect that these breakers, at least the 15 amp breakers, will overload and turn off before we get there. So let's just see what will happen. I'm going to put the camera directly on the panel over there so we can see how much of a percentage of load this thing is taking, and we'll start these things up slowly and one at a time and see what happens. And one thing I'm going to do is I'm going to make sure we can't cheat by unplugging this from AC power, so it can't borrow anything from AC while we test all this equipment and test the abilities of the inverter. This inverter will be supplying power to all of these things, or it should be, or it will be, only using the battery bank we have here. So here we go. All right, folks, the first thing we're going to light off is the cabinet saw, 220 volt cabinet saw. Here we go. 17%.
17%, now 15%.
Yeah, when it first starts up, it's an induction motor, so when it first starts up, it takes a little extra power, and then it settles down. Next thing we'll do is the shop vac. Here we go.
40%.
Okay. Next thing is the joiner.
At 101 now.
101.
But, oh goodness.
Okay, folks, we finished our first test here, and I went ahead and turned the inverter off. It went off, and then plugged it into AC. Turned it back on so that it could recharge our batteries for us here. It's just doing a fast charge on them because I'm not hooked up to solar yet while we're testing this inverter. So we're letting the AC recharge the batteries. It won't take long to get these back up. So did you have fun, Robert?
I did have fun. Well, I did. We got to plug in a lot of fun things.
We did. We plugged in and ran all at the same time using this inverter and battery power only. A small window air conditioner, a 220 volt cabinet saw, a jointer which pulls about 12 amps and has an induction motor, a 12 amp shop vac, a microwave oven that pulls about 13 amps, a 2 horsepower router, a 1.5 horsepower belt sander, and a heat gun. We couldn't get the hair dryer to come on because it had its own little GFCI that tripped. And I think that was all of it. We got up to 10,375 watts being yanked out of this thing before the 15 amp breakers on the panel failed. So that's a good sign. I mean, it's a sign that this thing can handle the load. We didn't get it up to the 12 kilowatts that it's rated for, although the panel here on the remote seemed to indicate that it got up to 104% of its ability at one point. That must have been when we were turning motors on for the first time and things like that. This machine is actually rated to take a load 3 times the amount of its current rating. Its current rating is 50 amps. So it can, for a 20-second period, it can take up to 3 times that much, or 150 amps, or 36,000 watts for up to 20 seconds in case you have a very large motor that you're having to start up, which pulls a whole bunch of electricity at once. So the limiting factor today, of course, was that it tripped our 15 amp breakers before we could get it up to that 12,000 watts. But I mean, it looks like this thing is going to be able to handle it, no problem. There was one point where we began pulling things and the overload and the alarm lights came on. It was so loud in here we couldn't hear the alarm. But that was to be expected when you're, pulling more than the rated amount on the load. So all in all, I think it was a good test and it was fun. We got to plug in a whole bunch of stuff. Now, the question is, are we ever going to have this much wattage being pulled out of the inverter at any one time, either while it's in the mobile generator or at Contentment after the house is built? So I'm thinking there's no reason why this couldn't handle everything that we would need at the house at Contentment.
Well, we don't have a refrigerator plugged in, which I know that is regular power, but you mentioned earlier that it doesn't constantly run, so we would have that possibly, and then we also maybe could have a dryer, but I don't know about that. A dryer at Contentment, please.
You have a dryer. It's called the Wind at very low humidity.
So what you're saying, am I hearing you correctly? You're telling me notice we are going to have to line dry everything?
Maybe.
Oh no.
Would that be so bad?
Well, I haven't done it since I was about 10 years old, almost 40 years ago.
Think of the advantages. No static electricity when you pull them out of the dryer.
But they'll be crispy.
Crispy how?
They're not soft. That's always what my mom said. I hate line dry clothes because they're not soft.
Because they're stiff.
Yes.
Hanging on the line. I don't know. Maybe fabric softener comes into that. I don't know how that works. Because the last time I saw clothes line dried was when I was a little kid. So.
Well, me too. Because, we talk a lot about this. My grandma Richardson had a clothesline. She also had a gas dryer, but mostly she preferred line drying clothes. And so I remember helping do that. Now, after my mom left the home, she never line dried clothes again because she wasn't about to go back to that kind of a lifestyle. And she has complained about them being stiff or not as soft as clothes dried in a dryer. So I don't know. So this will be an old new experience.
There is one advantage to not having a clothes dryer, whether it be gas, electric, wood-fired, whatever.
A wood-fired dryer?
And that is that you get to practice your skills at We will get to practice our skills, sorry. At heating up the old-fashioned iron by the fire and pressing our clothes out while they're still damp.
Do you know who has one of those? I come with one of those.
Do you really?
I do have one of those.
That's hot.
And
you're a true off-gridder.
you know what I also have?
What?
A butter churn.
Excuse me?
I do. You haven't seen it, have you?
No, I haven't.
Yeah.
It's hot.
I have some off.
Does it really work, or is it a decorative one?
Well, I don't know if it really works. It's been sitting in as a decoration forever.
Is it an antique, or I mean, is it a real one, or is it just like one made at a craft show for show that you sit next to potted plants?
I'm going to say it belonged to my grandmother, but I really don't know, to tell you the truth.
Really? So it could be a genuine butter churn.
You know what else I have?
What's that?
I have oil lamps, old schooly ones that belong to my grandmother.
Yeah, but we don't need oil
But
lamps.
I'm just saying, that's kind of off-griddy.
We need to give this thing a name. What should we name it? I mean, we're thinking about names for the mobile generator, and perhaps you can help us with that. But I wonder if the inverter itself gets a name, besides its brand name, Sigineer. If we're going to give it a pet name.
Big Bertha.
Big Bertha.
I like it because it's big and heavy.
So folks, here is my initial assessment and sort of overview of this inverter. I am impressed with the way this is built. It's got a great chassis on it. It's very heavily built. It appears to be very well made. It has a lot of UL listed components in it, which makes me feel good for the most part. And it just appears to have overall very good quality built into it. The things that I'm not crazy about with regard to its construction are the fact that it asks for 4-aught lugs, battery lugs, on these terminals, and I cannot find them. One reviewer I saw of this, High Tech Labs, he had two 2-aught lugs hooked to each terminal because apparently, and he never said, my guess is he couldn't find a 4-aught lug either. The other thing I do not like are those connection glands at the bottom of the inverter. They just appear kind of cheap. I mean, for lack of a better, I really don't trust them. I don't like them, and I would prefer to do either direct internal connections, or in future versions of this inverter, I think they should come out with a conduit pop out for the bottom of the inverter, where you can run conduit and a bushing in there, and actual mechanical load lugs that go into this to make it a little bit more safer. I mean, a machine with this kind of voltage and this much power and as heavy duty as it is, I think deserves more in the way of connections. The other thing I would suggest is, I'm sorry, were you going to say something?
Well, I was going to say, talking about the glands on the bottom, gland or gland?
Glands.
Either way. Okay. So anyway, regarding the location, if they're going to kind of keep that set up, move it. I don't know if it would be possible to move it, because when we were trying to put this on the wall, I was very, very, very concerned about a slip up and then it dropping on those and then totally wrecking the whole inverter. I was really worried and scared about that.
Which leads me to another strong suggestion for Sigineer, and that is install some kind of hoist hook on this, or large heavy handles on this, because this thing is so heavy. My guess it's somewhere around 180 pounds or something like that. This thing is so heavy that 2 grown men would have a hard time getting this on the wall, let alone she and I with a car jack. So, I mean, I strongly suggest some kind of handhold, some kind of hoist, something so that you can hang on to this thing while you're installing it and keep it safe. Because even for 2 grown guys, it's not safe.
But what if you had Dwayne "The Rock" Johnson helping you?
I think even if Dwayne "The Rock" Johnson were here helping me, because of this thing's size and because of the fact that it doesn't have a proper center of gravity, it's very top heavy here, very light on this end, even he would have a very tough time installing this thing. So
it is very cumbersome. I've said that before, and I will say it and say it and say it.
yeah.
That is probably one of the most difficult pieces of equipment I've ever had to handle. And I've handled a lot of equipment.
The other critique I guess I would give of this is the owner's manual. It's incomplete, and it's kind of sketchy in spots. It leaves you asking questions. Sigineer, one of the things I'm not impressed with is this owner's manual. It's basically a bunch of pages that are stapled together. It's not a great manual. I guess I would have expected something maybe in a booklet form or something like that. And under other reviews I've seen of this particular inverter, they did have owner's manuals that were in book form. So I don't know what to think of this, but the information in here is basic, and I would even say a little spotty. There are some things that I would have expected to see in here that I didn't. One might have been a wiring diagram for different configurations. I realize that this is not a grid-tied inverter, that it is an off-grid inverter with an AC charging capability that can sort of double as a de facto uninterrupted power supply in case there's a fluctuation in power or something like that. But it would have been helpful to have a wiring diagram that showed how you might wire this with a charge controller, if you have one. If you get an inverter that doesn't have the built-in charge controller. Also, wiring to a panel showing grounding and bonding to neutral if it's needed, or if it's not needed, just to be clear about those kinds of things, so that there's no mistaking and no chance of damaging the inverter. There are a few typos in here. I mentioned one about the 5-gauge wire doesn't exist.
So it doesn't exist anywhere, not even in Asia or anything?
Not that I know of. I mean, it may exist somewhere overseas. I did see a reference to 5-gauge wire online, but I've never found any 5-gauge wire. It seems like everywhere you go, it goes straight from 4 to 6. So, I don't know. I think also on the inverter itself, it would be helpful to have a little bit more information, a reading of the power factor on it. Sketchy in spots. It leaves you asking questions. It needs a better owner's manual, particularly for someone like me or another homeowner or someone who's building as a DIY or doing it yourself, doesn't have a whole lot of electrical experience, who's installing one of these. Would be very good to have a much better, more thorough, simpler, and more one with greater explanation. Put a few more pages in there and make it easy for folks like me, DIYers, to understand what's going on with this thing.
Well, you mentioned too maybe a schematic, because in some there's not really any wiring diagrams or anything like that, which would be very beneficial. I don't know if you tried to look anything up on the internet about that to see if there was any kind of a wiring diagram or something you could find.
There isn't. I got a hold of Sigineer, and they provided a couple of diagrams regarding this system when it's in AC mode versus inverter mode, but no other schematics or diagrams with this.
And in your email correspondence, you were talking with someone from Sigineer, is that correct? That was a good thing. How helpful was that representative?
It was by email, and the representative was very helpful. He was very communicative, got back with me quickly, answered my questions, I think, adequately. Overall, my experience with Sigineer was good, and I would actually recommend this machine. I would. I think it's very well made, and I think it'll hold up to whatever most people could throw at it. By no means is it industrial, quality or capability. It's not for that. It's for a do-it-yourselfer or a homeowner or a smaller application, simpler application. By no means is it anything like 380 volt or 600 volt inverters that you see out in the oil field or something like that that are mobile and moved around on gigantic trailers. but it will definitely do the job for most homeowners.
Well, we do have one more test to put it through. We haven't talked about that yet, but we have the 50 amp breaker, and then we have a 50 amp outlet here we're going to hook up, and the next step is not a dryer, since I'm line drying forever until I rot, but
I'll help you.
I'm just teasing, you know, I don't have a problem with that.
A small welder. Of course, you know, with a mobile generator like this and being used for construction, it'd be helpful to have something that will push enough amperage to supply a small welder. Most small welders, for what our need will be, usually pull about 30 amps. I'm going to plug it into a 50 amp plug just in case. This thing's rated for 50 amps with peaks to 150 amps if needed. So, there you go.
I'm just teasing about line drying.
Nice.
Big sexy.
Anyway, folks, that's my review of the Sigineer 12 kilowatt 48 volt inverter. And in speaking with the folks at Sigineer, in case you were interested in one of these, please contact me directly, because I've had some conversations with them. Of course, if you have any technical questions about the Sigineer products, you can contact me either through a comment on the video or otherwise through our Facebook page, Twitter, Instagram, any of those things, and I will get a note off the Sigineer and get you an answer. But anything else?
Yes, E-Chip. So, based on your overall experience, 1 being the worst, 10 being the best, what would you rate this beautiful machine that's going to be the lifeblood of Contentment?
Overall, I would say I'm very happy and satisfied with this. The hookup and handling aspects of this in the owner's manual, they give me enough things to be concerned about it. I would say I'd give it a, but its performance is great.
Average.
That's a toughie.
5 to 10,
Yeah.
5 below, you know, 5's the middle.
I'd say 7.5 to 8 on a scale of 1 to 10. Keeping in mind, of course, that if those things that I pointed out were fixed, man, I'd probably give it an 8.5 to 9, maybe even 9.5.
Well, I don't know as much about it as you do, but I've been very, very pleased with the performance because it's done everything really.
We threw everything at it.
Yes, and I mean outside of the, I don't know what to call it, this beauty. What would you call it?
What?
Outside of the problems with handling, overall you have this to perform a function, which is to be able to throw 48 amps worth of stuff at it, and it has done that.
It's doing it. It's doing it.
So.
Can't complain. It's not a bad machine, and I would recommend it. Let's put it that way. I'd recommend it. So if you have any comments or questions about it, please hit us up. We'd love to talk to you more about it. If you like this video, please subscribe to our channel. Please share, comment, subscribe. You can find us on Facebook, Instagram, Twitter, and of course YouTube. When you subscribe, be sure to click that little notification bell, and we'll let you know when more new videos are coming out. Come out every week, sometimes 2 a week, so be looking for us. We hope to be able to provide you more content like this. It takes quite a bit of time for us to do these videos, and so we appreciate your viewing them. Thank you so much for watching. Catch us on the next one in this series on building the solar generator.
Bye.